Hello everybody and welcome to this physics video which focuses on center mass and a couple example problems. First, the variable for center mass is denoted by the x variable with the cm subscript, and it is the variable x because it is positioned on the x-axis. With that being said, the center mass can also be located on the y-axis, but with the y variable. We have an idea how to find the center mass of a single object, but how do we find it if there is more than one object? This is where this equation comes into play. The center mass is equal to x1 times mass 1 plus x2 times mass 2 divided by mass 1 plus mass 2. x1 and x2 refers to the location or position of the masses. You might notice the ellipsis or the set of 3 periods at the end of the equation. This implies that this equation is not restricted to 2 masses, but can be adjusted to involve more objects. For example, this is the equation if a third mass is involved. If we want to solve the center of mass in the y direction, the x variables will be replaced with y. Let's move on to an example and use this equation. Two objects of masses 6.0 kilograms and 8.0 kilograms are hung respectively on the left and right ends of a 0.70 meter long stick. Calculate the center of mass. Let's assign both masses. Mass 1 is 6.0 kilograms, and mass 2 is 8.0 kilograms. We need to find the center of mass, but what is the position of the first mass and second mass? It might help to have an x-axis drawn to help us visualize, and we know the stick is 0.70 meters long. With that information, we can assign the position of the first mass as the origin, 0 meters. Then the second mass can be assigned a position of 0.70 meters. With both masses and both positions known, the center of mass can now be solved with a little algebra. The center of mass in the setup will be at 0.40 meters. Let's try a second example. An object has a mass of 120.0 kilograms and is set on a rigid beam with negligible mass at a distance of 3 meters to the left of the pivot. Another mass sits 4.0 meters to the right of the pivot, and the rigid beam remains balanced. What is the mass of the second object? Since the object is balanced on the pivot, we can call the pivot the center of mass. The pivot can also be labeled as the origin. With center of mass and position of both objects known, there is now enough information to solve for the unknown mass. With some algebra, the mass comes out to be 90 kilograms. There is something to note about this problem. The setup of the axis is flexible, and what I mean by that is where the zero position or origin is assigned. For the example that was just completed, the zero position was designated at the pivot point. However, another route could be taken by designating the left end of the beam as a 0 point. If this is a setup, the right end of the beam would be 7.0 meters, and the location of the pivot would be 3.0 meters. The center of mass equation can still be used, and the answer still comes out to 90 kilograms. Feel free to try it on your own to confirm it. This concludes the video on center of mass examples, and I hope you found it helpful. Thanks for watching.